Hi, I am Syed on Maths Online. Today's topic is Laplace transform of periodic functions. Let me first define what periodic function is. So a function f of t is said to be a periodic function of say period which is greater than 0 if it satisfies the condition f of t plus nt is equals to f of t, where the values of n is equals to 1, 2, 3 and so on. Which means that suppose if I am taking the value of n to be equals to say 1, so it is f of t plus, so t, where the value of n in this case will be 1. Suppose if I take the value of n to be 2, then we will be getting t plus, just replace over here the value of n to be 2, so you will be getting 2 times of t. Or if I put the value of n to be 3, so we will be getting t plus 3 times of t and so on. So for any values of n, the function should be equals to f of t itself. So whether it is f of t plus t, f of t plus 2t or f of t plus 3t, if the value ends with f of t itself, then the function f of t is said to be a periodic function. For example, this sin t and cos t are periodic function because it satisfies the above property. That is, sine of t plus 2n pi will end up with sin t itself. Then we call this 2n pi to be the period. Similarly over here, cos of t plus 2n pi is also equals to cos of t. Therefore, cos is a periodic function. One simple example if I take, suppose if I am taking say sine of say t plus 2 pi. So it is in the form of sine of 360 plus t. 2 pi represents 360. So sine of 2 pi plus t will be how much? Sine of t itself. We know this result. The simple result that you have studied earlier in your PUC, that sine of 2 pi plus theta will be equals to sine theta. So using that result, I have written this value. Similarly, suppose if I take cos value, it is cos of t plus 2 pi. So cos of t plus 2 pi is also equals to cos t itself. Alright. So therefore, you're getting back the trigonometric function sin t as well as cos t. Therefore, we call this sin t value as well as cos t value, this sin t as well as cos t value to be periodic functions. Let's take the theorem. If f of t is a periodic function of period t, then Laplace transform of f of t is 1 by 1 minus e power of minus of st. It is integral 0 to t e power of minus st f of t into dt. So whenever f of t is a periodic function of say period t, then your Laplace transform can be written in the form of 1 by 1 minus e power of minus st integral 0 to t e power of minus st f of t. So now let us take few example based on this formula. So the first example is if f of t is equals to t square, where the value of t lies between 0 to 2, and f of t plus 2 is equals to f of t. For t greater than 2, we need to find out the Laplace transform of f of t. So let us see what is the period of this function. First we need to find out what is the period of this function. You can find out from here, it is t plus t. So it is in the form of f of t plus t is equals to f of t. So then we say that the function f of t is a periodic function. So in the question it is given, it is f of t plus 2 is equals to f of t. So which means that the period in this case is 2. So given that the given function is having period t to be equals to 2. Alright, so if that is the case, and the value of f of t given over here is t square. So in that case, because this function f of t is a periodic function of period t, we can use the formula. So the formula that we have is L of f of t is equals to, it is 1 by 1 minus e power of minus of st, it is integral of 0 to t, it is e power of minus st f of t into dt. That's the formula we have. So let us try to use this formula. So it is a Laplace transform of, we know that f of t is t square, so let us replace the value of f of t to be t square. It is 1 by 1 minus e power of minus of capital T, we know capital T is 2, so I'll try to replace the value of t to be 2, so it becomes 2 times of s, so I can rewrite that as 2s. Then you have integral 0 to t value is 2, it is e power of minus of st, f of t value is t square into, it is dt. Or further, if you want to simplify this expression, we know that you are having product of two functions, so I'll be applying the Bernoulli's rule over here. So if you want to apply the Bernoulli's rule, you have to take this value to be u, this value to be v. So in the previous videos I have told you, you have to just use the Eilert principle whenever you want to use the Bernoulli's rule. So algebraic function t square is there, and the exponential function e power of minus of st. So therefore the first function is t square, so I'll be taking that as u. The next function is e power of minus st, therefore I'll be taking that as v. So we already know the Bernoulli's rule, it is u into v times of dt will be equals to u into v1 minus u dash into v2 plus u double dash into v3 minus and so on, where u has to be differentiated over here and v has to be integrated. So let us apply the Bernoulli's rule over here. So I am applying the Bernoulli's rule. So this will be equals to, it is 1 by 1 minus e power of minus of 2s, it is u into v1, u value is t square into v1, I have to integrate this e power of minus st, so e power of minus of st divided by coefficient of t is minus of s, u into v1 minus u dash, u value is t square, differentiation of t square will be 2t into, here the constant that we have is minus 1 by s, so I am taking the constant outside. Now integrate e power of minus st, so e power of minus st will be e power of minus st divided by coefficient of t is minus of s plus u double dash, that means you have to differentiate this 2t, differentiation of 2t will be 2 into constants, I'll try to eliminate, so this is minus value over here and minus over here, so minus of minus will become plus, you have 1 by s into s will become s square into integration of e power of minus st will be e power of minus st divided by coefficient of t will be minus of s. So because this 2 has become constant, further differentiation of 2 becomes 0, so you have to stop the Bernoulli's rule, and the limit values that we have is t is equals to 0 to 2, those are the limit values over here, this is 0 to 2. Let's apply the upper and lower limit values over here. 1 by 1 minus e power of minus of 2s as it is, I will take the common value minus 1 by s, apply the upper limit value for t to be 2. So 2 square will become 4 in the first term, and it is e power of minus of t will be 2. So it is 2 times of yes upper limit value minus the lower limit value for this t square. T is equals to 0. 0 into anything will become 0 itself. That's the first term. Now move on to the next term. So in this term you can just multiply. Negative of negative will become positive. Positive of negative will become negative. So it is 2 by, in the denominator s into s will become s square. Now I need to apply the upper and lower limit values for t e power of minus st. So t value will be 2. It is e power of minus t value will be 2. So 2 times of yes upper limit value minus the lower limit value for t will be 0. So 0 into anything will be 0 itself. Coming to the last term over here, it is positive into negative will be negative. It is 2 by s square into s will be s cube. Now apply the upper and lower limit values. It becomes e power of minus of t is 2. So 2s minus e power of t value will be 0. So 0 into anything will be 0 itself. So e power of 0. So we applied the upper and lower limit values. Further, let us try to simplify this one. It is 1 by 1 minus e power of minus of 2s. So we have minus 4 e power of minus of 2s divided by s. It is minus 2 times of 2 is 4 e power of minus of 2s divided by s square. Then you have minus of 2 by s cube e power of minus of 2s. I just open the bracket and multiplied these two values. Just multiply it. Then again you have to multiply the same value with this particular expression. So minus of minus will become plus. It is 2 times of, and e power of 0, we know e power of 0 will be 1. So just 2 in the numerator divided by s cube. So that's the expression we have. Further, I can take the LCM there. So this term will remain as it is, 1 minus e power of minus of 2s. I am taking the LCM over here as say s cube. So if I am taking s cube as the LCM, I will be getting the expression to be equals to over here minus 4. In the denominator s is there, to make it s cube. Numerator I will multiply by s square. S square e power of minus of 2s minus 4 into. So s square is there in the denominator. To make s cube, multiply by s in the numerator. S e power of minus of 2s minus this value will be as it is. It is 2 e power of minus of 2s plus this value 2 as it is. So further, s cube we can take common outside and rewrite this one. This will be equals to, it is 1 by s cube is taken common outside. You are left out with 1 minus e power of minus of 2s. First I'll write the constant 2 as it is. Next I'll take negative sign outside. So I can take common value over here. It is 2 times of e power of minus of 2s will be common. So what will be left out inside? The first term, because negative sign is already taken outside. So because 2 is taken common outside, you are left out with 2 times of s square. The second term, negative sign is already taken. That will become positive. 2 is taken common outside, you will be left out with 2s. Then here negative sign is taken common outside, positive will become 2 e power of minus of 2s is taken outside, you are left out with 1. So that will be the expression in the numerator. Further, if you try to observe over here, 2 is common throughout, so I can take 2 common outside divided by s cube into, it is 1 minus e power of minus of 2s. And you are left out with, say it is 1 minus of, you have 2s square plus 2s plus 1 times of e power of minus of 2s. That will be the required solution. Let us move on to the next question. Find the Laplace transform of the full wave rectifier f of t is equals to e sin omega t, where the value of t is lying between 0 to pi by omega. So let us try to solve this problem. So let us try to see what is the period over here. So period will be, if you want to calculate the period, you should always write down the final value minus the initial value. So you should always write down the final value minus the initial value. Final value minus the initial value. So your final value in this case is pi by omega minus the initial value is 0. So from here you can write down the final value as pi by omega minus the initial value as 0. So therefore you will be getting the period to be equals to pi by omega. So this period is nothing but your t value. So t value is known, it is pi by omega, and it is given that f of t is nothing but e sin omega t. So let us use the formula and try to solve this problem. So we have the formula to be equals to L of f of t is equals to, it is 1 by 1 minus e power of minus of st, it is integral of 0 to t, it is e power of minus st f of t into dt. So that is equals to, it is 1 by 1 minus e power of minus. Now substitute the value of capital T to be equals to pi by omega. So pi by omega into s will be pi s by omega. It is integral of 0 to t value is pi by omega. It is e power of minus of st. F of t value is, it is e sin omega t into dt. So if you try to observe over here, this value of capital E is a constant. So I can rewrite this as, it is E whole divided by, it is 1 minus e power of minus of pi s by omega. It is integral of 0 to pi by omega. It is e power of minus of st. It is sine of omega t into dt. So this is nothing but the standard formula. The standard formula that you have learnt is e power of ax sine bx into dx. So the formula for this is, it is e power of ax by a square plus b square into, it is a sine of bx minus b cos of bx. So this formula you already learnt. So I'm just using this formula. So if you try to compare over here the values, so this value that you have, x value corresponds to your value of t, because try to see it is dt, so dx. So x value will be t, and coefficient of t is minus s. So in this case coefficient of x is a, so the value of a will be, here a value is minus of s. So you can see this particular a value over here is a coefficient of t which is minus of s over here. So a value is minus of s, and the value of b, if you try to compare the value of b over here, b corresponds to your omega value. So therefore you have b to be equals to omega. So we have got the values of a, b and x value. Now we'll try to simplify the expression by using the formula. So if you try to use it, this will be equals to, it is e divided by 1 minus e power of minus pi s by omega. So you have this particular formula, e power of ax by a square plus b square. So it is e power of a value is minus of s, x value is t, divided by a square plus b square. So a value is minus of s, so minus of s square, b value is omega, so we'll be getting omega square. times of, it is a value is minus of s into sine of, b value is omega, x value is t, minus b value is omega, it is cos of, b value is omega, x value is t. And limit values that you have, limit values is running from 0 to pi by omega. So let us try to apply the upper and lower limit value for both the terms. So this will be equals to, it is e divided by 1 minus e power of minus pi s by omega. So if you try to apply the upper limit values over here, so your upper limit value will become, it is e power of minus t value, upper limit is pi by omega, so it is pi s by omega. If I try to rewrite it, whole divided by the denominator value minus of s whole square will be s square plus omega square, and over here you have, it is minus s times of, it is sine of omega into, so your value of t will be pi by omega minus omega into, it is cos of omega into t value is pi by omega. So this whole is your upper limit value. Alright. So now once upper limit value is complete, now let us move on to the lower limit value. Lower limit value minus of. Alright. So lower limit value is e power of 0. So let me write down this whole expression, the upper limit value in the bracket. So this whole I have written in the bracket. So here I need to close the bracket for this term, another bracket. So this whole is the upper limit value minus the lower limit value is, it is e power of t value is 0. So divided by s square plus omega square into, what do you have, minus s times of sine of, t value is 0, 0 into omega will be 0, minus omega into cos of, t value is 0, 0 into omega will be 0. So this is your lower limit value. We see that this omega and this omega will cancel out. This omega and this omega will cancel out. And since you are getting sine of pi value over here, we know that sine of pi value will be 0. So this will become equals to 0. Here sine 0 is there. Sine 0 value will also be 0. So we have cos of 0 over here. Cos of 0 will be 1. And in this case, you have cos of pi value. Cos of pi value will be minus of 1. So all these basic values you need to remember. So now if you try to rewrite, we get it as, it is e by 1 minus e power of minus pi s by omega. You have e power of minus pi s by omega divided by s square plus omega square. So this first term is 0. The second term has become minus of 1. So this minus 1 multiplied by minus of omega will become plus omega. Right. Then coming to the next term here, minus e power of 0 will be 1 over here. E power of 0 is 1 divided by s square plus omega square. Here first term will be 0 minus cos 0 is 1. 1 into omega will be omega. Further, let us try to simplify this expression. You have, it is e divided by 1 minus e power of minus pi s by omega. So here the first term you have got omega e power of minus pi s by omega whole divided by s square plus omega square. In this case, minus of minus will become plus omega by s square plus omega square. So if you try to observe over here, you can take common values to be omega by s square plus omega. So which will be equals to, it is e omega you can take common divided by, you have 1 minus e power of minus pi s by omega, and here you can take s square plus omega square as common. So if that is the case, you will be left out only with e power of minus pi s by omega plus 1. That's the expression will be left out. Alright. So therefore, you have got the expression to be equals to e omega times of 1 plus e power of minus pi s by omega. It is whole divided by, if you try to rewrite the denominator value, you will be getting s square plus omega square. It is times of 1 minus e power of minus pi s by omega. So that is your Laplace transform. You can further simplify this expression and try to get in some standard form. Now for that, what I'll try to do is, I'll just try to multiply and divide by, it is e power of pi s by 2 omega. So we'll just be multiplying the expression by pi s by 2 omega. The reason why I'm multiplying this by pi s by 2 omega is, so if you want to get the standard form in both these terms, you have to get the exponential value. Here also, both the term. But in the first term, you're getting 1 here, you're getting 1. So I need to get an exponential term. So to get an exponential term, I'm multiplying this by pi s. I would have multiplied only pi s by omega, but I'm multiplying pi s by 2 omega so that both these terms has to match. So this expression is in the form of minus 1 times of pi s by omega. If I multiply that by half times of pi s by omega, so minus 1 plus half will become minus half. Minus half times of pi s by omega you will be getting both in the numerator as well as in the denominator. So to get that expression, I am multiplying that by e power of pi s by 2 omega as well as I am dividing it. So let us try to multiply and see what is the expression you'll be getting. So that will be equals to e omega by s square plus omega square will remain as it is. Now let's try to multiply e power of pi s by omega. So if I try to multiply in the numerator, I'll be getting e power of pi s by 2 omega plus e power of, as I told you, you have minus 1 over here. I am multiplying, if you want I'll just show it over here. It is e power of minus pi s by omega is the second term in the numerator. You are multiplying that by e power of pi s by 2 omega. So when bases are the same, powers can be added. So e power of, I have pi s by omega common. So first term will be minus of 1. The second term will be half. Alright, just taking pi s by omega, and because I'm just adding it, so pi s by omega is taken common, so we'll be left out with minus 1 plus half. So minus 1 plus half will be minus of half. So it becomes e power of, so minus half plus 1 will be minus of half. So it becomes minus pi s by 2 omega. So try to rewrite over here. You will be getting minus pi s by 2 omega. This whole divided by the denominator, all the same thing. I need to multiply this by e power of pi s by 2 omega minus of the same thing you are doing in the denominator also. You will be getting e power of minus pi s by 2 omega. So that's the expression you will be getting. So if you try to observe this particular result, so you will be getting the expression to be equals to, it is e omega divided by s square plus omega square. So the numerator value corresponds to the hyperbolic function. It's 2 cos h times of 2 cos h pi s by 2 omega. Right. So denominator corresponds to your sine hyperbolic function, 2 sine h times of pi s by 2 omega. Because you are having a 2 over here, this 2 and 2 will cancel out in the numerator as well as in the denominator. You have cos by sine, so cos hyperbolic function divided by sine hyperbolic function corresponds to your cot value. So you will be getting e omega divided by s square plus omega square into, so this represents cot h times of cot h pi s by 2 omega. That will be the required solution. That's all I have for today. Thank you.